Okay, now we're finally up to the homework problem. So here's the first one that was given to us. Prove that if the function x equals cosine x, then f prime of x is equal to negative sine of x. So this is really an insignificant thing to do to give us the answer, but it's just an indicator that he wants us to show our work. So let's forget about negative sine of x for now, and find just find the derivative through the standard method that our professor provided us. So we know the derivative is going to be the limit as this h goes to 0, right? This was just a standard little quotient formula that we were given and that we used to calculate limits. F of x plus h minus f of x over h. And this is actually a lot easier. The trigonometry function might put you off a bit, but it's actually much easier than it looks. So let's go to let's just plug it in, right? So, well, substitute. My teacher would get mad if I used the term plug it in. So we can now have this cosine of x plus h minus cosine of x, all of that over h. Okay, so we got one step further, and now cosine of x plus h, what does that remind you of? Or really, where does that come from, if we recall from trigonometry? And if you don't remember, you can look into your appendix at the back of the book to see what I'm talking about. Cosine of x plus h, or really cosine of alpha plus beta, let's just use x plus h for now, is equal to this is something I just sort of memorized, cosine, sine, and I know we have x, h here, x, h here, and let's not confuse that with a hyperbolic cosine. These are all variables. And let me stick in my multiplication sign. So we have this conversion that we can use to help us solve the problem. Let me put this down here for now. So, we can basically now plug this in. Well, substitute. It's a habit. So, we can replace this now with the principle of substitution with cosine of x times cosine of h minus sine x times sine of h. So we're actually pretty close to the answer. And let's keep in mind, I always forget to do this, that we have to keep this notation constant. We haven't, this doesn't equal cosine x plus h, it equals the limit. The limit has to be present. So let's keep that in mind here also, that as we continue, this is still only a limit. And we have to use this anyway later on. We can't just negate it. So as not x but h, as h approaches 0. Okay. So now we can, let's see, we have a cosine x here and a cosine x over there. So basically we can get these cosine x's and factor them out, right? And if you don't recognize what I'm talking about right away, just look here. Let's take that cosine x, move it here, and now we have two factors, right, that we can factor out. And this, of course, this cosine x is multiplying 1, so 1 would be left behind after we factor it out. So let's take a look at it. Cosine, we just factored out the cosine x minus cosine x, and it basically leaves behind a 1. So That's our formula right now, and that's pretty much as we can break it up. Well, not break it up, but all the conversions we can do with trigonometry. Oop, 5 minutes left. Let me hurry up. So now, what we want to do is we want to distribute this limit as much as possible. First of all, let's split this one giant fraction into two fractions first, and we'll probably turn it into more fractions later on. So take that negative and stick it there. So I hope you're keeping up with what I'm doing. And now, so we just split this up into two fractions. Now we can take this limit and actually just distribute it to both the fractions. Okay, so hope I didn't lose anyone. Just watch the video over and over again to see exactly what I did. And now from here we're going to use the product rule and distribute this limit into this little area here. So cosine x can come out, that can go here, and we're going to have the limit of this entire little quotient here. So, does anything seem familiar so far? Well, maybe not yet. Let's move this up and create more space for us to work with. So, the limit of, let's start trying to find these limits. Let's see. I have to move this to the left like that. Okay. So, and recall that this is multiplying. So, what's the limit as h approaches 0 of cosine of x? Well, h is not a factor here, right? So we can't basically have a limit here. So basically we have to negate that limit. And let's see, what else do we have? So the limit as h approaches 0 of cosine h minus 1 over h. Haven't we seen this before? Of course we have. We saw this in another slide a while ago. This slide right here, where I just showed that the limit as theta approaches 0 of cosine theta minus 1 over theta is equal to 0. We proved it. So basically we have all we need to basically confirm that this limit here is equal to 0. So let me take this. That's weird. Okay, and that is multiplied by 0. Alright. Now let's try to find the limits over on this side. So we can split this up, right? We can split this fraction up. So we can take the sine of x out of the numerator here and just have limit of h is 0 of sine of x times multiplication times the limit of h is 0 of this quotient. So we found ourselves in a similar situation again. We can't take the limit as h approaches 0 of sine of x because there's no h here, so it's a non-fact. We basically negate that limit, and now we have the limit as h approaches 0 of sine of h over h. Now we proved through the squeeze theorem that sine of theta over theta, or sine of 0 over 0, is equal to 1, right? So cosine of x, no matter what it is, times 0 is going to just become 0, right? So we are pretty much done with this problem. So we've just proven this is equal to 0, and we can negate that 0 now because 0 minus sine of it, it's just going to be that, and we could get rid of this multiplied by 1. So now we know that the f prime of x, so let's bring down our original, that our f prime of x is equal to negative sine x, and I just showed all the work, and I hope you got that. Am I under? Yes. Alright, see you in the next video.